So let's finish up these notes with 4 word problems, because truly the only reason that we learn to do algebra is so that we can solve problems. And when we only know a little bit of algebra, we can only solve little problems. They don't get terribly exciting sometimes, but still we're working our way up. We're learning to translate words to algebraic expressions to solve an equation. And the only way to solve word problems is to use words. A lot of folks don't like to use words in a math class, but you have to identify what you know and what you don't know, and then write a sentence that shows the relationship between what you know and what you don't know. If you can write that sentence, writing the equation will be very easy. Label known quantities and use algebraic expressions to represent unknown quantities. Write a sentence that relates the quantities to the unknown quantities, and then it'll be easy to translate the sentence to the equation, solve the equation, write the answer, including units, in a way that would make sense to the person asking the question. If somebody's asking you a question, it doesn't make sense to answer x equals 7. That person doesn't know what x is. So answer your question in a way that it would make sense to the person asking the question, and then check your answer in the original problem, not just your equation. Because if you've set up your equation wrong, you may have an answer that is a solution to your equation, but it's not the answer to the original problem. Let's start number 1. A total of $15,000 is to be divided between John and Wendy, with John receiving $2,500 less than Wendy. How much will each receive? Again, if you only know a little bit of algebra, you can only solve little problems. And this is a little problem that you may be able to figure out without setting up an equation at all. But we're practicing changing words to algebraic expressions. So I'm going to go ahead, even though I could probably solve that without setting up an equation. That's what I'm working on. What's known? And Justin, do you want to talk to me, or do you want me to talk to myself? You just listen. All right, I'll just talk to myself then. The 15,000 is what's known. That's the total. The total is 15,000. What's not known is how much each person has. We don't know what Wendy has. We don't know what John has. I'm just going to write Wendy's dollars and John's dollars. And I don't know how much either one has, but I do know that John has 2,500 less than Wendy. I know if I could figure out how much Wendy has, I will just subtract 2,500 to get what John has. I don't know what Wendy has. That is what I let be X. X is something I don't know, and Wendy, I don't know anything about the amount of money she has. I know if Wendy has X dollars, then John has 2,500 less than that. So I'm going to call John's amount X minus 2,500. And then the sentence that makes sense using these words that I've written is that Wendy's dollars plus John's dollars equals the total dollars. And it doesn't matter if you're in a math class or at Walmart, that sentence makes sense. Wendy's dollars plus John's dollars is the total dollars. And if, like I said, if you can write the sentence, the equation is easy. For Wendy's dollars, that's what we let be X. John's dollars. That's what we let be X minus 2,500. And total dollars, we were told is 15,000. So that's my equation. And when I to solve that equation, I need to combine like terms. Add 2,500 to both sides. And then divide both sides by 2. I think that would be 8,750, 16, 1750. Yes, I think that's right. But the answer is not X equals 8,750. John and Wendy don't know what X stands for. So that's not what I need to give for the answer. I need to say Wendy has $8,750. And John has, how do I determine what John has? Well, he has 2,500 less than Wendy. So if I subtract 2,500 from Wendy's, I would get 6,250 dollars for John's part. And that makes sense to the person who asked the question. To check my answer, I don't want to just check my answer in the equation because I may have made a mistake in setting up my equation. I want to make sure that my answers actually satisfy the words. So does John have 2,500 less than Wendy? I can subtract, and yes, he does. Do they really have a total of 15,000? And add and see that yes, they do. So I'm pretty confident about that solution. All right. Number 2. Outdoor Outfitters marks up the wholesale price of a 2-man tent by 30%. The selling price is $377. What's the wholesale price? When I'm considering something that's being marked down and marked up, some words I might want to use are the wholesale price. I'm going to call that original price just because in case you don't know what wholesale means. I'm looking for the wholesale price. So that's my unknown. Original price. And that's what I'm going to be. Let be X. It's the thing I'm looking for. Now I need some words for these other two numbers, this 377. That's how much the tent sells for. So I'm going to say the selling price is $377. And 30%. I have to be careful with my words here. I'm not just going to call it the markup. It's the markup rate, but it's not the amount of markup. I'm going to call it the markup rate. And 30%, we always write percents as decimals when we're solving problems, so I'm gonna write it as 0.30 or just 0.3. Now, I need to make a sentence using these words. I need to think about if I, let's say if I was Outdoor Outfitters and I was trying to figure out how to get that $300.77 that this sells for. I know when something's being marked up, you start with the original price. And you don't just add 30 cents, you add 30% of the original price. So the original price plus 30% of the original price. That's how you get your selling price. Just to see if that sentence makes sense, let me play like I'm buying a pair of jeans for $50 and it's been marked up 5%. I would take, or let me make it easier, marked up 10%. If I had $50 pair of jeans and it was marked up 10%, I'd say 10% of 50 is $5. I'd add that $5 back to the original 50 to get my selling price, which would be $55. So I understand that. That makes sense. The sentence is the hard part. In the place of original price, I'm going to put X. In place of 30%, I'm going to put 0.30 or just 0.3. Of the original price means times the original price. And that is my $377. Solve my equation. I'm going to combine like terms. Left-hand side, 1.3x equals 377. And I can't do that in my head. So 377 divided by 1.3 is 290. X equals 290 is not the answer to the question, because the question, what question asks, what's the wholesale price or what's the original price? So the answer is the wholesale price was $290. And to check that, I would take 30% of $290, 0.3 times 290. 0.3 times 290 is $87. If I add that back to the 290, do I get 377? Yes, I do. So I'm checking my answer with the words, not just the equation. Two more, and one of them I went all creative on you and used clip art for a garden rather than just a rectangle. I was feeling especially creative. Number 3 says a rectangular garden. Let's say we're talking about this side of the garden right here. Here's my rectangle. Has a length which is 4 meters longer than twice its width. The perimeter of the garden is 28 feet. To really make sense, I should say perimeter of this side of the garden. I just realized that didn't make sense according to my picture. But if I'm only talking about the perimeter of this side, I can say that the perimeter is the thing I know. And that's 28 feet. And what I don't know is the length and the width. What I'm looking for. So I'm going to need to use some algebraic expressions for the length and the width. This is telling me something about the length. The length is 4 more than twice its width, but I don't know anything about the width. So I can let the width be X, or I can even let the width be W. W makes a little more sense for width. And the width of a rectangle is always the short side. So the short side is W. And then the length is 4 more than twice that. Well, twice the width would be 2W. And 4 more than that would be 2W plus 4. And using these words, excuse me, using these words, I can make a sentence for how I find the perimeter of a rectangle. I'm sorry, my voice is going. Perimeter of a rectangle. Perimeter of a rectangle is 2 lengths plus 2 widths. So my sentence is 2 lengths plus 2 widths is the perimeter. In place of the word length, I put my algebraic expression for length. 2W plus 4. I need that in parentheses if I'm going to double it. 2 lengths plus 2 widths. My widths were just W's. Equals my 28. Solve that equation by distributing the 2 like terms. I'm going to go ahead and subtract 8 from both sides. Made this problem up and I thought I'd made it up where my width would be a whole number. Looks like I didn't. And I divide both sides by 6. I get the width is 10/3. And when I'm solving a word problem, it probably makes more sense to write that as a mixed number. The width is 3 1/3. Since it asked me for both length and width, my length, go back to the expression that I wrote for the length. It's 2 of those widths plus 4. And that should be 6 2/3 plus 4, which would be 10 2/3. For the length. I put my units on there, and using W and L, you can tell which one's the width, which one's the length, so I'm not going to write a complete sentence there. I do want to check that twice the length plus twice the width is 24, or excuse me, 28. So I'm going to check this on my calculator real quickly. 2 of those lengths plus 2 of those widths. I'm just going to punch it on my calculator and see if it's 28. I know that would be 21 and, let's see, 20 4/3, 21 1/3. This would be 6 2/3. And sure enough, if I add those, that is 28. So it would take me a minute to check that on the calculator, but it does check. All right. Last one. And we may just set it up and, well, I don't know, we may solve it completely. This reminds me of the equation that we solved about when you take 3 tests in the final and the final counts twice. I said this equation could be used to solve for what you needed to make on the final to get any average you wanted. This problem's very much like that, but rather than the final counting twice, the final counts 2/3 of this person's grade. Going into the final, and the final's 2/3 of his grade, Mike has test scores of 86, 80, 84, and 90. That's how many points he's already earned. 86 plus 80 plus 84 plus 90. If I divide that by 4, I will get his current average. The average going into the final. Let me see what that is real quickly. 86 plus 80 plus 84 plus 90 divided by 4. He has an 85 average right now. The unknown is what he needs to make on the final. I could let that be X, or I could let it be F for final. His final exam score, let it be F. Now I've got to make a sentence with all of that. And I know his final counts 2/3 of his grade. That means his current average counts 1/3 of his grade. So 1/3 of current average plus 2/3 times his final equals his course average. His current average is 85. So 1/3 times 85 plus 2/3 of whatever he makes on the final. He's trying to get a B in the class and he has to have at least an 80. That at least tells me I'm not solving an equation here, I'm solving an inequality. He wants to make at least 80, that means greater than or equal to 8. To solve it, the easiest thing to do would be clear out the fractions. Common denominator's 3. I'd multiply all 3 terms by 3. Put it in red just so you could see it well. The left-hand side, that 3 goes into 3 1 times. And 1 times 85 is just 85. Your second term, 3 goes into 3 1 times. And 1 times 2f is just 2f. And on the right-hand side, 80 times 3 is 240. Back 240 from both sides. 155, I think. 230, yep, 155. And then divide both sides by 2. And that would be 77.5, I think. I'll have to check that. 144, 154, 155. That's right. Mike must score at least 7.5 on the final. Check that. I would just take 1/3 times his current average plus 2/3 of that 77.5. Just going to make sure that it would give him at least 80. And then I know if he makes more than 77.5, he would have a higher average. All right. I'm sorry that ran long, but if it helps you, it was worth it for me. I think it's worth it for you too. Have a great day.